Lesson 5, Unit 1. This is Lesson 1.05. In this first video, we are going to discuss some vocabulary words. We're going to start with this word, congruent, or I should say congruent, as it's said out in the West. Let me write that word down. Okay, congruent means having the same size and shape, or having the same shape and size. Okay, so two geometric figures are congruent if they have the same shape and size. So for example, just to show you something that you'll be learning at some point about triangles, this triangle, I'm going to try to draw a second triangle exactly the same. I already kind of made that line a little wavy, but you can get the idea. If these two triangles are exactly the same shape, they're not really quite the same shape, but if they were exactly the same shape and size, they would be congruent. Let's talk about line segments. Any two line segments that have the exact same length or the exact same measure are congruent. So let's take a look at these two line segments. Let's assume that this is point A, B, C, and D. And let's say that the measure of AB equals the measure of CD. If that's the case, then line segment AB is congruent to line segment CD. And notice how we represent congruence. We often do it by having an equal sign, and then above the equal sign we have a squiggly line. So line segment AB is congruent to line segment CD. Let's do our next vocabulary word, midpoint. Midpoint. You can probably guess what midpoint means. It is the point that divides a line segment into two equal parts. Okay, so for example, if I have the line segment EF, okay, and let's say I say that the measure of EF equals 10. If I have a point G between E and F, and if EG equals GF, meaning the measure of EG is the same as the measure of GF, then G is the midpoint of line segment EF, written like that. Okay, good. Now let's talk about a related concept, which is that of a segment bisector. A segment bisector. We get a fresh sheet of paper here. So a segment bisector is a line that divides a segment into two equal parts. Okay, so a segment bisector is a line that divides a segment into two equal parts. So let's go back to our midpoint here. And here we showed that G is the midpoint of EF. If we had a line that went through G, let's say we create a line going through G like that, and let's say we call this line HI. Okay, we have two other points on that line, H and I. We could have also called it HG or GI. Now we have a line that is dividing segment EF into two equal parts, and we can say we can say that line HI in this diagram is a segment bisector. Okay, we can say HI is a segment bisector because it is dividing EF into two equal parts. Okay, good. Our next word, equidistant. Okay, equidistant. And we say that those are 2 points that are the same distance from a given point. Are equidistant from that point. Okay, so let's say we're given 3 points, A, oops, what did I write B? Okay, let's start that again. A, B, and C. And let's say that the measure of AB, which is the distance from A to B along that segment there, is equal to the measure of BC, which is the distance along that segment there. Okay? If that is the case, then we say that A and C are equidistant from point B, from B. So A and C are equidistant from B. We sometimes will represent this in a diagram by drawing a line, like one notch between each of these 2 line segments, and that's sometimes shorthand for showing that they have the same measure. You can also draw 2 notches through each of them, and that might also be shorthand for showing that they have the same measure. There's a concept we're not going to be dealing with just quite yet, but we are dealing with it indirectly when we use a compass, and that is a circle. Because when we take a compass and we are using it, what we're actually doing is we're actually drawing circles. So if I put my sharp edge, my sharp point of the compass here, my pencil here, and I rotate the compass around, oops, I can't change the setting of the compass, so let me rotate the paper around a bit. I'm going to have to do this again because I don't have enough room really to rotate this large piece of paper. So I'll do the best I can. I'm going to try rotating the compass around. That. So I kind of moved it. Let me keep doing it. It is definitely something that takes a little bit of practice. Move it around like such. And I've drawn it rather faint, but you can see that what I've drawn is a circle. Okay, we all know what a circle looks like, so let's talk about its definition. A circle is defined as a set of points in a plane that are equidistant from a given point in the same plane. Okay, we call that given point, which was where I had the sharp edge of my compass, the center of the circle. So this is called the center. And we call the distance from the center to the circle the radius. You may have seen some of these terms before. And finally, the last definition I want to discuss is that of parallel lines. Now, we did mention parallel lines in a previous video, but just in case you didn't have a chance to watch that video, let's look again at parallel lines. parallel lines are two lines that are coplanar and do not intersect. So that, for example, this is what parallel lines might look like in the plane of this paper. Okay, these lines are going exactly in the same direction, so they will never intersect. Okay, compare this definition to that of skew lines, which we talked about in class. Skew lines are two lines that are non-coplanar and do not intersect. Okay, so we already talked about skew lines. These lines would not be skew lines. They would be parallel lines because they are in the same plane. Okay, in the next video, I'm going to be demonstrating a construction.